So the first couple questions are multiple choice, just because I wanted to practice a little bit of multiple choicey questions. Not exactly super conceptual, although it can be if you want it to be. The last couple questions are free response type questions. They range from really hard questions, quote unquote, to not so hard questions. I'll give you guys a second. I'll give you a second just to think about it.
When it's in the X, the smaller it gets, it stretches. Oh wait, hold on.
It's, yeah.
No.
The amplitude is 2.
No.
No,
It's A. No.
It's A. Yeah.
Oh, guy, hold on. Read it.
It's A.
Read it.
I read it. It's A.
I will ask, and then I will point out at someone to tell me. Stop yelling it out, because some people need to think about it.
It's a joke.
Yeah, it's pretty good at reading.
Yeah, it is good. It is really good.
What do you look when you look at this? You just go like amplitude period.
Okay. All right. So, see me. What would you pick?
A.
Yes.
Why?
Because it starts at 2.
Okay.
So that means that the amplitude is 2.
That's number one. Yeah. So it starts at 2. So A has to be 2. That's number one.
So you know B and D.
Since it's starting at 2 and not in the origin, you know that it's cosine.
Yep. Must be a cosine function. Cosine of something.
And really, that already gives you the answer because that's the only thing. The 2 pi t, I mean, 2 times pi is like, it's kind of harder to see just because of the...
So just know that when the X is being multiplied by more than 1, that it's going to shrink. The period shrinks.
That's true.
Period 1.25.
The period is not 1.25. The period is about... Oh, wow. Okay, it's shifted over. The period is about 1.
That you divide that by 2.
Wow. Okay, it's still shifted over.
That's pi.
The period is 1. So remember that the second form, or one of the forms, was 2 pi over period times time. One of the forms was x of t. That does not look like a t. X of t equals a cosine 2 pi over period t. And the period looks to be about 1. So it turns into 2 pi times t. Okay, not bad. Yeah, I agree. The answer is A. And often, those are the things you should look for. So I don't know who, I think it was Johnny who said, what is it that you do? Do you look at the period? Look. There are certain things that you should, if you don't know literally anything about simple harmonic motion as a whole, remember that the type of motion is modeled by sines and cosines. So if you remember some things about sines and cosines, it will help you a lot. For example, you can eliminate any sine function here because it doesn't start at 0. Right? You also know that the maximum for every regular sine or cosine function is 1. So if this function goes above 1, or below 1, it needs to have a coefficient in front of it.
Will it ever have shifts though?
It can have a shift. It can. There are certain special shifts that do special things. For example, if you have a shift of 90 degrees, then you can turn sine into cosine or cosine into sine. You can do that. That makes it much harder to see if you have a shift. Okay? What about this guy? Here we need to apply. Give it a second. Let him read. Did you flip the page already, David? All right. Give you guys a second. I'm glad you got an answer, though. Makes me feel confident. For the record, we're going to have a quiz on simple harmonic motion and then a test on simple harmonic motion. And then probably a quiz on rotational motion. Not rotational motion, sorry. Rotational dynamics, torque, and angular momentum. Actually, no, I'm sorry, other way around. We're going to have a quiz on simple harmonic motion, then we're going to have a test on simple harmonic motion and torque.
Simple harmonic motion and torque.
Torque, yeah. So at the end of this week, we're going to have a quiz on simple harmonic motion by itself. That's it, because I want it to be short so that we can use the rest of the class period to keep going with torque. And then...
When you say at the end of you do that Friday?
Yes. I believe that's the end of the week. And then No, that's not even me being sarcastic. Like, I don't even know anymore when we do and don't have class, man. Like, I don't know. That stuff's weird. So, all right, David, you got a proposed answer?
Oh, no.
Or a question?
Not at all, yeah.
Try it. Dude, try it. Why not? What's the worst that happens?
Yeah, but just a question. Oh, yeah. Are we doing both at the same time, rotational and simple harmonic?
We already had our quiz-ish on rotational. It was kind of ish.
We didn't even get into torque.
Oh. No, okay, that was rotational kinematics. Now we're going to go into rotational dynamics. So that's going to be torque and angular momentum and moment of inertia.
So it's like, yeah.
Wait, so for now we only have the
For simple harmonic motion, which will be small. It will be at the end of the class on Friday, and that way we can just keep moving with stuff. It will literally be tiny. Simple harmonic motion. It's not, like, look through this. It's not that bad, I think. It'll be okay. All right, so anybody have a proposed solution that's not Simi? She already did it, and she's very gung-ho about it. It's not cosine? Why is it not cosine?
Derivative. No, you also know the derivative. It's the derivative of position, and the position is the same graph as before. Or even if you see position, you know that it's cosine, and the derivative of cosine is sine.
Okay, so that eliminates E, so it definitely can't be E. Okay.
It also has to be.
Well, it has to be.
It has
It's gonna be negative because
Because
the
their
derivative of
cosine
cosine
is negative.
Okay, so that eliminates what?
A.
A? Okay, eliminates A.
The amplitude is gonna stay 2.
The amplitude is going to stay 2?
No, it's not.
Oh, wait, no, what was
No,
the
it
original
doesn't.
one? Hold
It
on.
doesn't. You have to multiply the inside.
Okay, what's that called?
Um,
Say that again? It's called the chain rule. I got to multiply by the argument.
It's gonna be one of the 4.
It's going to be one of the
and
fours.
it has a pi, so it has that's what you're the number. So you're also multiplying the pi out. So it has
That leaves me with D.
Boom.
Okay, so what was the position function? From our last one,
Why does it need a pi out?
well, from our last one, from number 1, we got 2 cosine. Oh, you know what?
It's C, right? Yeah.
No, it is D. Okay, so that was our position function, right? How can I get a velocity function from this? Take the derivative. So x prime of t. So I'm going to take the derivative, and I can do this using a u substitution if you want to do that, or whatever. Chain rule, it doesn't matter. So the 2 doesn't do anything. The derivative of cosine is. So I'm going to end up getting a negative 2 sine of 2 pi t, except I have the t here is not by itself. I have to chain rule this guy. So times the derivative of the argument times 2 pi. What is negative 2 times 2 pi? Negative 4 pi. Sine.
The way I was thinking of doing it, other than that, is that you know the tangent line is line from 0 at 0.5 and 1. Or I'm just trying to choose one.
Does it give you the same thing?
Yeah.
It should. Yeah.
Yeah.
Okay. Questions?
And it's easy.
So there are a couple of things that you can do if you don't remember all of the like I told Johnny a second ago. If you don't remember everything about simple harmonic motion, understanding the relationships for position, velocity, acceleration, and the nature of sines and cosines will help you a lot. All right? I mean, you guys know what the pattern is already, man. What is the acceleration of this thing? Give him a second. Give everybody a second to think about it. Before giving me an answer, think about what can I eliminate. Yep, all of them are based on the same thing.
That's why you guys were all so confident.
Yes. Yes. And very often they'll do something like that. Like they'll give you one big graph and say, for the next 3 questions, this is all about this graph. Okay, so what can I eliminate?
Anything with sine.
Why?
The derivative of sine is cosine.
Why do I have to take the derivative of sine?
Because acceleration is the derivative of velocity.
So I can look at the previous question. I know that the velocity graph was a sine, so the derivative of that is cosine. Anything that has a sine is gone, so there goes A, there goes B, there goes D. Okay, that's cool.
Oh, you're going to pi squared. Okay, yeah.
You need to have a pi out. You're taking the derivative twice.
outside twice.
That is true. I'm going to end up there's no way, taking that derivative, there's no way I'm going to get rid of that coefficient. Right? So bare minimum, I should at least have a negative 4 pi somewhere, right? Like maybe some craziness happens, maybe, and I don't add another 2 pi. It can't happen. But there should at least be a pi somewhere chilling. So that eliminates C. So that leaves me with E as an option. We also remember we can solve this if we think about the relationship between the displacement or the position, whatever, and the acceleration. We know that they are maximums at the same time, but in opposite directions. So if we know what the position function is, if it's a cosine function, then we know that the acceleration function will also be the same, but it will have an opposite sign.
Wait, why is it type 3?
Because if I take the derivative, we had velocity
You already had a pi.
was 4 pi, there was a negative in there, right? Negative 4 pi sine 2 pi t. If I take the derivative, when I do chain rule again with the argument inside, I'm going to get a second 2 pi that's going to multiply in here. It's going to make this a negative 8 pi squared. And in general, if you remember our 3 equations for simple harmonic motion, in general, they looked like I'm not going to write it in that form. Oh, actually, I'm not going to write it in that form either. You will be given them in one form. Nope. So if you remember our standard form for position, velocity, and acceleration, you'll see that the coefficient in front keeps getting bigger and bigger by an order of magnitude every time. Okay? Bonus question. Where, at what times, is the kinetic energy greatest?
V squared, the highest velocity. So the slope is the highest.
This one was about velocity. So can you tell me, you have an equation, tell me at what time is the kinetic energy greatest?
You know, the highest velocity.
Okay, what time is that? You have paper, you have pencil, you have a calculator. What time is that? How can I find that?
I'd say
Can you look at the graph then?
I can do that as well. I'll take either solution. I would prefer that somebody do it mathematically to see if you know how to do that. But
I'll try.
the acceleration to what?
The time where the critical point of energy is.
Yeah, that's what I'm
Okay.
Yeah, I'm solving for acceleration equals 0 to find the extra amount, and then based on that you find which is the max.
Okay,
and
so
just plug that in.
find me that.
Yeah.
For the record, this graph here is a graph of position.
Yeah.
So you keep doing you. You keep doing you. Those of us that are not doing the finding the critical point thing, what would you look for on the graph of position to find the times of the maximum kinetic energy?
Wouldn't it be when time is 0.5?
Can I say it?
Yeah.
Oh, you'd look for the steepest point because the derivative,
No,
the
Okay.
slope of the
The
position
steepest
function.
positive.
No, well, look for the steepest
No,
one.
absolutely.
Then you realize
What you can
that's
also
where
do-
the greatest
Hold on, wait.
So then you know that it's positive. So you find the greatest positive.
Well, did I not say the greatest kinetic energy?
Is that what you said?
You did.
I did say. Where is the greatest kinetic
Okay,
energy?
so that's what I'm saying. So then you look for the positions where the slope is the greatest.
Okay.
Yeah, but what you could do is.
That is actually very true and very useful if I had very general kinematics. Very general. But I can apply some knowledge of simple harmonic motion.
I would just get the acceleration.
T is
T is
1/4.
1/4.
That is true. So what time is that?
T is 1/4. What do you mean?
What time is that?
0.25.
0.25. Yep, that is true. And? Oh, wow.
0.75.
Yep. And?
0.25.
Yep. Because you're right.
You have to find where the inside equals
The inside of what?
of sine, the argument,
Of which function?
Of the velocity.
Of the velocity function is.
Set it equal to 1 because sine of not 1 pi over 2 because at pi over 2 sine is the greatest.
Okay. Yes.
So then that's going to give you the greatest value.
So there's 3 ways we can solve for this, right? I like your graphical way. In general, if I had any graph for any kinematics, the steepest for position versus time, the steepest point would be the fastest, right? Because the slope of position versus time is velocity. Not bad, okay? But I can take advantage of some simple harmonic motion knowledge, and we know that when the oscillator is at equilibrium, that's when all of its energy is in kinetic. So it will be moving the fastest. So I can look at the graph and see where this crosses 0 and find those points. So that's another way of doing it. I could also take the acceleration function, set it equal to 0, and solve for those points, finding the extremes. Okay, I could do that as well. Or I can take the velocity function, and we know that that is a maximum when the sine of theta is maximum, right? So when does sine of theta become maximum? When the argument is equal to pi over 2, or
3 pi over
3 pi over 2. Any, n pi over 2 plus n? Pi? Yeah, or plus?
Plus pi over 2 plus...
And any multiple of... Plus,
Well, plus half pi. No, plus pi.
okay, yeah, that makes sense. Plus...
Pi, yeah.
Well, it would be plus n pi. It should be plus n pi, because then it would be any multiple, any oscillation over. Yeah, plus n pi. So you have a bunch of different ways of getting to that same answer. Just like I could say, at what times does this have a minimum acceleration?
Like the smallest acceleration?
Yes. When does it have a minimum acceleration?
And the velocity is the
That points for the second derivative is 0.
That's true. At points when the
If the pattern changes.
When there's the least amount of area.
where is the least amount of acceleration? Where's the minimum acceleration?
At the
Why?
Because what I said with the extrema is that a equals 0.
That is true. So that's a very general kinematics answer. That's very true. But we also know from simple harmonic motion that what causes the accelerations?
A change in velocity.
No. What in a simple harmonic system, what always causes the acceleration? Actually, in any system, what always causes accelerations? It rhymes with Morse's. Force. A force. And if this thing is simply harmonic, then the force has a very specific condition it has to satisfy. It must be restoring. It has to be a restoring force that is dependent on displacement away from equilibrium. So the force has to be some form of K delta X. It has to be some form of that, where K can be literally anything. It could be spring constant. It could be mg over L, whatever. It could be anything. It could be a coefficient, right? So that means if this is a simple harmonic system, then the force is minimum when the displacement is minimum. If the force is minimum, then the acceleration is minimum. So if we know a little bit of, yes, you can totally do it knowing general kinematics rules, right? Find the minimum of acceleration graph and do that. Or you can just look for where delta x is 0. Because if my kinetic energy is maximum, my velocity is the biggest. That only happens at equilibrium. At equilibrium, my delta x is 0. If my delta x is 0, my force is 0. If my force is 0, my acceleration is 0. It's quick, right? Like it sounds like it's a lot, but if you get to this point where you can kind of spit this all out, it'll make you. It feels good. Like you get like and it all kind of comes back together. It all holds hands, and it's great. All right, hold on. Let's go. I think that's it for multiple choice. Is that it for multiple choice? Oh, there is one more. Okay. Haha. So we've got a pendulum. We're going to assume it's a simple pendulum just to make our lives easy so that we can do some simple harmonic stuff. Make life okay. It is brought to an angle of theta. So it's displaced an angle theta. And then released. Which one of these, by the way, the letter got cut off, I assumed, because we are AP, and this one is the first one. We all assumed that was A.
That's a heavy assumption.
I'm just saying.
I think it's on purpose. It's empty. There's nothing exponential.
It's not.
Okay. Well, okay, so which one of these is the accurate energy versus time? Energy versus time. Now they say that's true. They say gravitational potential. That's very true. Okay. Well, it's not position versus time. It's okay. That does make a difference. That is very true. You have a guess?
Top, at the two tops,
Yes.
it would have the highest H.
Yes, I agree with that.
It has the same mass at every position.
That's true.
The
That is true.
It's the height.
That's true.
The height is the highest and the smallest.
That is true.
Which would at a starting point at a point at which it changes direction. So that means, which means everything in the middle is going down until
Decreasing.
it decreases until its peak, and then it'll increase.
What do you mean by its peak? You mean it's
And not peak. It's
equilibrium. You're talking about this
Yeah,
point,
yeah,
this
yeah.
point here? Yeah, equilibrium. Okay, I agree.
Or it'll continue to decrease from there until at which point it'll start to increase.
Okay.
Which rules out B, C,
So it rules out B. It rules out, what did you say? C. I mean, but to be fair, this could be a maximum but negative.
But if the A is already
I was thinking
there,
about that, but
Potential energy is also always
yeah,
positive.
energy's always positive.
Okay.
That's fine.
Okay. And then E, you said, yeah, I 100% agree with you on E. It definitely does not do what we just said it should do, E. Okay, so that leaves me with A and D. So what is really the fundamental difference between A and D?
A is exponential, B is linear.
So, well, okay. We don't, it could be exponential, or it could be, I forgot the word already. Okay, quadratic, yes, but polynomial. It could be polynomial of even degree, right? But considering that the butt ain't fat, it's probably not anything bigger than 2, right? Because you guys know that the bigger you get from 2, the fatter you get that bottom part. Like it starts to widen out, right? You get thick. Yeah, I feel you. Okay. Okay, so I've got what I imagine to be a quadratic. It's probably not exponential because the exponential function definitely doesn't do this part. Yeah, definitely doesn't do that. Exponential would actually look more like that, right? That would be exponential. Okay, so what are we thinking? Oh, I got A, I got D, I got D.
I was in A initially, but then it's true that MGH is linear.
That's very true. MGH is linear. That part is I agree with. That part is very true.
I think it's
That's
A.
also true.
It doesn't just like stop and like come back. It like
Like,
diminishes and grows.
That's true. David's got an answer.
Okay, yeah. Okay, so potential is MGH, right?
Yes.
But just because that's linear doesn't mean it's linear. It's because this is a graph of position versus energy, and this is position like energy MGH. So H is dependent on X.
You also have kinetic energy. 1/2
No, but
kx
it's only
squared.
the gravity.
what? You just made an argument.
Yes, but
Wait. I got two. Wait, guys. I got 2 arguments going, and both are good arguments, and I want everybody to hear both. So let David finish, and then I want to hear not his argument.
There's a linear correlation between distance, the height H and X, which is true. They are proportional. Like, linear.
Okay, but the restoring force was some form of mg sine theta.
No, it's MGH.
No, the restoring force was some form of mg sine theta, right? So what is the relationship between forces and energy? Especially if it's a conservative force. Remember that the negative integral of force is the negative integral of potential is force. No, other way around, sorry. The negative integral of force is potential. There we go. Bless you. The derivative of potential is force. Yes. Okay. No. Okay. But now, hold on. I want to hear Nati's argument. That was a good argument.
Even though we're graphing gravitational potential, as you have less gravitational potential, it's because it's shifting to kinetic energy because the ball is swinging. Kinetic energy is 1/2 kx squared. So it wouldn't be weird if the graph was.
I really like that argument because, and I want her to say it one more time. Say it one more time.
Okay, so even though we're only graphing gravitational potential energy, you can't ignore the fact that when it increases or decreases, it's because of its relationship with kinetic energy, which is
1/2 mv.
1/2 kx squared. Which is
No, that's potential. That's spring potential. You're talking about 1/2 mv squared.
What?
You're thinking about spring potential, 1/2 k delta x squared. But you're right. It is a quadratic. It is a quadratic relationship. It is a quadratic relationship. The energy conservation, the rate at which energy is flowing here, is not linear.
I didn't realize it's not the same as everybody change.
Yeah.
Wait, what?
Exactly. There we go.
Can we?
Congrats.
All right.
You see how like it gets smaller and smaller and smaller, but then it's bigger and bigger. The difference is bigger.
That is true. So that is true. More than that,
The lines are.
Go.
They do cancel out, but graphically, you're gonna get that.
Give it a crap, you're gonna get
How?
so
One thing that's
Yeah,
no.
I realized that once I saw it.
the rate of change of the energy from conservation of energy is not linear. The way that the gravitational potential energy changes from the top to the bottom is not linear, because kinetic energy does not increase by a linear factor, it increases by a quadratic factor.
Sure. The potential is linear.
Fine, but now it's a balancing act, right? My kinetic and my potential, they have to reach this equilibrium of sharing, right? The rate at which the energies start to transfer. If I have a rate, that's absolute value of x. That's what that function is. And that means if I tried to, no, let me not say it that way. That means that the corresponding force that would create that potential, right, is linear. But it's not exactly. It's not linear.
No, it's quadratic.
Exactly.
No, but that means the corresponding force is quadratic. Because the derivative of
Well,
line
we know that the gravitational force is gm1 m2 over r squared,
What? Oh yeah. Wait, sure.
right? But we can simplify that to mg. But inside of that g, there is a capital G m r squared.
Wait, how do we get to gravitation? Oh, because.
Gravitational potential energy.
Oh, okay, sure.
So inside of that g, there is a quadratic term in there. Well, it's an inverse quadratic, but there is a quadratic in there,
Yeah.
right? So the rate at which these energies change is quadratic. And actually, if I wanted to graph the kinetic energy, it would look like that. The kinetic energy would look like that because it would have to mirror the rate of change of potential in the opposite direction. And at every single point, if I add them up, I should always get the exact same number because energy must be conserved.
But when you say force is the negative integral of energy?
Yes.
Yeah, so the integral of a line is a quadratic. Right?
Can you explain that?
Wait,
out?
linear.
We'll talk to me after. We'll go because this was something we saw way back in dynamics. So we'll talk. We'll talk. All right. I do want to get to this guy because it's quote unquote a 3-star problem, but it's actually not really. So I'm going to give you. I don't want to hear anybody say an answer. I want you to try it, and then I'm going to call out somebody. 32. You going to stick with Dion? Yeah. I liked Dion. He was a good guy.
Which one do you think it is? Lewis, Waiters.
I'm just glad we're no longer Wait County, and we're back to being Wade County. Although, to be fair, I really want him to retire.
I remember wearing the Christmas jersey, the Wade Christmas jersey, from like the day I bought it.
Dude, I want one of those Vice jerseys, but like, I know, man, they're so pricey. Man.
Question for you. Period is the
Capital T.
That's just a capital T.
It is just a capital T. Just a capital T. Living in a lonely world. Rode a midnight oscillator down anywhere.
Can I have an equation sheet? Yeah.
Boom. Gotta have it. All the time.
Oh, you kept one.
No,
Uh-huh.
I'm not gonna lie. I just kept the quiz.
Ah. I would definitely have kept them from your notes if you have them from your notes. I do not have any extra equation sheets. I will say that the general form of an oscillator's position, generally, as we saw a second ago, was
2 pi over TT.
something that kind of looks like that. Granted, there are also some substitutions that we can make.
Yeah, it was 2 pi over.
It's a cosine though.
Oh, well, ain't that crazy. Ain't that crazy. All right, do I have any proposals? Anybody close?
Wait, I'm working on
You remember it with
Wait, period and average takes to complete one full cycle.
Yes.
so funny.
I have no game.
Oh my god.
When was that?
You don't remember it?
What's her name? The one I hated. Oh no, not Shula.
No, it was with Shula. Because then she gave us the whole thing after the stink file.
Wait, are we streaming to this?
Wow, those were good times.
You guys are wasting like
Hold on, guy, I can't even hear David's good question, man.
Can we assume it's a spring or something like that?
It's something with simple harmonic motion. Could be a spring, could be a pendulum, could be anything, but it's guaranteed to satisfy everything for simple harmonic motion.
Without knowing what it is.
No, I don't know specifically exactly what the force is,
Oh, okay.
but I know for sure it satisfies simple harmonic motion. For sure.
Okay.
Okay, I got an answer. I don't know if it's right.
Okay? So tell me what to write. Where do I go?
Oh, I'm supposed to count it again.
Why not? Let me know. Where should I start? What's the first thing I should probably do?
Why would you grab it?
Because my class wasn't doing what class should do.
So do it yourself. Just inverse.
What should be the first thing I do?
Okay, your x of t is equal. I just wrote it
What?
as normal. It's a cosine of.
I'm going to write my givens.
Oh.
The first thing I'm going to do. So what am I given?
You know the period.
I know my period. Okay. I know my amplitude. Now, do I need to convert that amplitude to meters? If they were asking me for a position or something, it would be a great idea to do that. If the numbers that they gave me were all in different units, it would be a great idea to do that. But everybody's in the same units, and I don't have to find a position. What's going to end up happening is I'm going to probably divide positions and positions. So it's going to end up canceling something. So I'm going to leave it alone for now. If I need to convert, I'll do it in the moment. Okay? So I know that. What else do I know?
So that it has an equilibrium at x equals 6 centimeters.
I would say it's not at equilibrium at x equals 6 centimeters because that's the amplitude.
No.
It was, right?
Whoa. No,
Wait.
yeah.
It's
Amplitude,
7.5.
but that's starting from equilibrium. That doesn't matter. It's just,
That it's a distance away from equilibrium.
exactly.
Yes.
So I'm saying that x equals 0 is a negative amplitude, and x equals 12 is positive.
If
where I got that from is, look, it says instantaneously at rest at x equals 6.
so, what does that tell
Only
me?
at rest, instantaneously at equilibrium.
So if it's instantaneously at rest,
Yeah.
that means its velocity at that point is 0.
Which means that you have an equilibrium at x equals 6 seconds. 6 seconds.
If the velocity is 0 at that point, it's not an equilibrium. The velocity is maximum at equilibrium. What's up, Ben?
Don't you just have to find negative 1.5?
So I want to know the time. I want to know the time it takes to negative 1.5 centimeters. So I need a function.
I did.
Tell me what to do.
I did negative 1.5 equals using the equation on the board where
Why is it negative 1.5?
you have to calculate the time it takes the object to go from x equals 6 to x equals negative 1.5. And you know,
6 is the equilibrium.
yeah, and it tells you.
Hold on. 6 is not the equilibrium. It is the amplitude.
Yeah, that's
Okay?
what
Okay, so negative 1.5 equals.
Equals 6 sine of 2 pi over 3t.
Wouldn't it be cosine? Because as t equals 0, it says it's at rest.
So over. Well, I just wrote it as t, capital T, period. So it should be over 0.3, right?
What's x of t?
Over 0.3.
So x of t is the position function, right? Where this thing is. Now, Ben wrote sine. And when we first started looking at these things, we said it could be sine or it could be cosine. How do we pick?
Depending on where it is at the origin.
It depends at time t equals 0, depends on where it is, right? Now, here at time t equals 0, they told us the object is instantaneously at rest at the amplitude, right? If it's at rest at the amplitude, the velocity function should be 0 at the amplitude. That means it will not be 0 for position. It'll be maximum for position. So the position function that starts at maximum when t equals 0 can't be sine, because sine always starts where?
In the origin.
At 0. So it should not be sine.
Wait, why did you equal to negative 1.5?
It should be cosine. Okay. So what I'm doing, what I should probably start with is say my position function in general equals a cosine 2 pi over. Oh yeah, I could write it as omega t, but I don't know omega. So I can make a small substitute. I could find it, or I could make a substitution and say that omega is 2 pi over t, 2 pi over period times t. So there's my position function, right? Now we can fit things in. What is my amplitude? 6 centimeters. What is my period? 0.3 seconds times t. So this is x of t. Now x of t represents what?
The position.
Where I am at some time. So what does it want me to find? The time at negative 1.5. So I'm going to plug in negative 1.5 for x of t and try to solve for that t. So negative 1.5 centimeters. You know what? I'm just going to erase this guy real fast so that I don't have a bunch of stuff all over the place. Equals 6 centimeters times cosine of 2 pi over 0.3 seconds. You are more than welcome to replace that with a number. If I divide that by 6 on both sides, I'm going to end up getting rid of my centimeters, which is okay, which means I don't have to convert this to meters. Beautiful. That's one less thing I have to do. I'm going to end up getting a quarter, 0.25. Okay? So negative 0.25 equals cosine of 2 pi over 0.3 seconds t. Now this is the other thing that's really important. When I go to do arc cosine or cosine inverse, doesn't matter, I need my calculator to be in radians. You need it to be in radians. When I go to put this in radians, what will I get? When I go to do cosine inverse, I'm sorry, what will I get?
You will get cosine inverse of negative 0.25 times 0.3 over 2 pi equals t.
Okay, yes. I was hoping you'd give me a number, but yeah, you're right.
It's about 0.09.
It needs to be in radians, right? Because if this is in centimeters and this is in centimeters, I need this guy to be unitless. I need it all to end up being unitless.
Well, seconds. You need seconds, but you need it to be universal, so it's not degrees per second.
No, well, yeah, I'm talking about this up here. If I divide the centimeters over, I need everything to be unitless. So then the time that I get should be what, about 0.0?
0.087.
If I don't have this in degrees, in radians, I'll have it in degrees. Or you could have it in gradients, I guess, whatever. And you'll get about 5 seconds. And on the AP, that option will be there. It will be there. And you have to sit there and reason this out. Like,
It sucks because for everything else in physics, it has to be on degrees.
yeah. Think about this. Think about it logically. For everything else, what you mean is for any vector quantity. Whenever you see a vector quantity that's given to you in degrees, they're going to want you to do it in degrees. But you could turn it into radians if you want to.
Right, I know.
But the reason why we do this stuff in radians is because I need it to be a unitless quantity. So it's actually not that bad of a problem. The number one thing that I need to do is remember that this is a cosine function, not a sine function. If I tried to do this with a sine function, that option will also be on the AP exam if this was a multiple choice.
The answer since X
That is the answer, 0.09. If you would have done this with radians, with degrees, or you would have done this with sine, you would have gotten a much bigger number, and you're going to have to sit there and reason. That number is going to be bigger than 0.3 seconds. That doesn't make a whole lot of sense, right? Yeah. What you're doing here technically is solving for the first time it gets to this. Because it will get to this value for every multiple of 2 pi, right? Because it's going to come back to that number, keep going, and keep going, and keep going, cycling back and forth. It will hit that number, 1.5, over and over and over again. And this is technically only solving for the first time. How is it that you get a number that's bigger than the period for the first time? That doesn't make a lot of sense. So it's a really good thing to just double check if the thing that you're getting makes sense. I think the bell's going to ring in a second. These next ones are actually this next one itself is actually really good. This one was straight from an AP exam, specifically 1986, question number 3.
1986.
What? Surprisingly, right?
College Board existed in 1986.
College Board has been around since I think like the 70s or whatever. AP has been a thing for a long time.
I haven't signed up.
You probably should. You probably should.
My mom doesn't know. My mom doesn't. I have to do it all.